We continue learning workbook page 139. Let's complete some LX problems. Given g of x equals the principal square root of the sum 5x plus 40, and h of x equals x subtract 5, find g composed with h of x. Okay, we begin by rewriting this using the definition as g of h of x. We note that the input is a variable, and therefore we work from the outside in. We start with function g, which is this function, and we write it, but everywhere we see an x, instead we're going to put h of x. Okay, now we can substitute and simplify. We know that for this problem, h of x is equal to x subtract 5. So we get the square root of 5 times the difference x subtract 5 plus 40. Because the thing that we are substituting has a multiplier, we use parentheses. All right, now we can simplify this problem. We'll distribute. So this goes here and here, and we get 5x subtract 25 plus 40. Combining our like terms, we get the principal square root of the sum 5x plus 15. This is our final answer. If you'd like, you can write your answer as g composed with h of x equals the principal square root of the sum 5x plus 15. Both are acceptable as far as I'm concerned. Okay, let's try another example. G of x is equal to x squared subtract 3. H of x is equal to x fifths. Find g composed with h of x. Okay, this is going to feel very similar, especially for the first two steps. So this is going to be g of h of x. And because we have a variable as our input, we're going to work from the outside in. We're going to start with function g, which we see here. But everywhere we see an x, we are instead going to put h of x. So we need to figure out what is h of x squared subtract 3. And we know that for this problem, h of x is equal to x fifths. So x fifths squared subtract 3. And because h of x had an exponent, when I replace it with something new, that new thing needs to be in parentheses. Okay, now we're going to simplify this. So x fifths squared is just an x fifths times another x fifths. And then of course I'll do the subtract 3. X times x is x squared. 5 times 5 is 25. So we get x squared over 25, subtract 3. Final answer. If you'd like, you can write g composed with h of x equals x squared over 25, subtract 3. Okay, let's do one more example. Our last problem is interesting. We're only given one function to use. Given h of x equals 2 over the product 5x. with the restriction that x is not allowed to be 0. find h composed with h of x. All right, this is the first time we've seen the same letter twice, h and another h. But the idea is still the same. If f composed with g of x is rewritten as f of g of x, then both f and g are going to be replaced with the letter h. And we get that h composed with h of x is equal to h of x. So we're going to rewrite this as h of x. And again, we note that there is a variable for our input. So we work from the outside in. We begin with function h, which we see here. And we write 2 over 5, but in place of this x, we put h of x. Now we substitute and simplify. 2 over 5 times, and h of x is 2 over 5x. Let's simplify this even further. 2, which we can write as 2 over 1, divided by 5, which we can write as 5 over 1, times 2 over 5x. These 5's can be canceled. They're both factors, so they turn into the number 1. And so now in my denominator, I'm going to have 2 over x. The rule for dividing fractions is to keep, change, flip. So I get 2 over 1 times x over 2. These 2's cancel. They each turn into the number 1. And 1x over 1 is simply x. So the answer of this question is x. Or if you prefer, you can write h composed with h of x equals x. That concludes the ALEX problems for this topic.